Hello, my dear students. Now we are talking about the inheritance of two pairs or more of contrasting traits. We said before the inheritance or transmission of only one pair of contrasting traits like yellow seed and green seed of pea plants. Okay, but now we are talking about the inheritance of two pairs or more of contrasting traits. Okay, let's see the mental experiment. Number one, he conducted a mixed pollination between two pea plants. One of pure tall stem and red flower. As we said, we will study two traits. Pure tall stem and red flower. First one. Second pea plant with pure short stem and white flower. Okay? Who can tell me how I can write the symbol of tall stem and red flower? Tall stem is a dominant trait, so I will represent it with the first letter capital, T capital. It's a pure, so I will write the two letters similar. As we said before, any hereditary trait represented by two letters, two factors, two genes, okay? Yes. What about the red flower? Red flower is a dominant trait, so I represent it with first letter capital, dominant trait. What about the second letter? It's pure or hybrid? Yes, it's pure, so I will write the second letter also R capital. Okay? What about pure short stem? Short stem is a dominant trait or recessive trait? Yes, it is a recessive trait. So, recessive trait of which trait? Tall stem. So, I will write T small. I don't need, when I talk about recessive trait, I don't need to listen a pure. We said before, any recessive trait is a pure, always pure. Okay? What about the white flower? White flower is a recessive trait of red flower. So I will write the small letter of dominant trait, which is R small. Okay? Again, Mendel experiment. He conducted a mixed pollination between two pea plants. First pea plant of pure tall stem and red flower. Second pea plant with pure short stem and white flower. Okay? After that, he planted them to see the first generation. What about the first generation? We will see now. First generation. As we said, number one, on the left side, we will write parent gametes of spring in a circle or in a square, rectangle, and so on. Okay? Parents, gametes of spring. Okay? Parent. What about the parent? We said the parent will be one of parent, tall stem, red flower, T capital, R capital, as we said. Okay? Second parent, short stem, white flower. So, T small, R small. Parents, like that. After that, we will make the gametes. How we can write the gametes? The gametes, we will take the first factor of the tall stem with the first factor of red flower. So, it will be T capital, R capital. Okay? Second gamete will be second factor with second factor. T capital, R capital. Okay? After that, the gametes of short stem, white flower. We will take the first letter, T small, with the first letter of white flower. So it will be T small, R small. Second gamete will be second factor with second factor. T small, are small. Okay? Number one, we wrote the parents on the left side, at the top of the left side. After that, we wrote the gametes. Now we will make a distribution of gametes to form the offspring or to form the first generation. Okay? Let's see how we can make a distribution. We will take the first gamete with the second one. Sorry, the first gamete with the first gamete from one parent to the other parent. So it will be T capital, T small, R capital, R small. Okay? After that, we will take the first one with the second one. So it will be T capital, T small, R capital, R small. Okay? After that, we will take the second factor with the second one with the first one. So, yes, it will be T capital, T small, R capital, R small. After that, we will take the second one with the second one. So, it will be T capital, T small, R capital, R small. What you observe from that? Yes, all the offspring from the first generation plants had tall stem. All of them had first letter capital T, T capital, T capital, T capital. Tall stem. And red flowers. Red flower, they carry capital letter of R, 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 R. Okay, so all the first generation plants had tall stem and red flowers. Carry the dominant trait at ratio what? At ratio 100%. All of them carry the dominant trait at ratio 100%. Okay? But what about the trait? The trait, pure or hybrid? Yes, it will be dominant trait, strong trait, but hybrid. Okay? Hybrid, mixed. T capital, T small, R capital, R small. All of them dominant but hybrid. Okay, 100%. Okay, after that, after first generation, Mendel left the first generation plant to self-pollinate. Means he took from the first generation like a parent of the second generation. Tall stem with red flower, tall stem with red flower. But pure or hybrid? Yes, hybrid. Let's see the second generation. But before we see the second generation, we have a lot of gametes. So we will put them in a table of 16 cells to be more easy, like that. Okay, what about that? The two parents, as we said, hybrid, dominant hybrid, pea plant of tall stem, and red flower, but hybrid. The first parent. The second parent carry dominant trait, but hybrid. Pea plant of tall stem and red flower. Okay? How we can write the gametes? We will write the table like male gametes and female gametes. How we can write the male gametes? We will take the first factor. We will take the first factor of tall stem is the first factor of red flower and write them C capital or capital. After that, we will take the first factor of tall stem with the second factor of red flower. So it will be C capital or capital. After that, we will take the second factor of tall stem with the first factor of red flower. So it will be C small or capital. After that, we will take the second factor of tall stem with the second factor of red flower. So it will be C small or okay. That's about the gametes. And the female gametes like male gametes. Okay? After that, what we will do? We will take the first one with first one of male gametes. So it will be C capital, R capital, R capital. And first one of female gametes with second one of male gametes. So it will be C capital, R capital, R small. After that, we will take the first female gamete with the third male gamete. So it will be C capital, small, R capital, R capital. Okay? Finally, we will take the first female gametes with the fourth male gamete. So it will be C capital, small, R capital, R small, and so on. For the second one, third one, fourth one. We will take the second one with first, with second, third, with fourth. Okay? For that, we will take the third one of female gametes with first male gamete and right, second male gametes and right, and so on. Okay? So we will have a table of 16 cells. Male gametes, okay, above, female gametes at the side. Okay? It's very easy and very simple. Okay? And make a table like that. Write on the table the following. The traits of the individuals of second generation. What about the traits of individuals of the second generation and their ratio? Number 1, tall stem and red flower. Let's see how many offspring or in the second generation have tall stem and red flower. C capital, R capital, 1, C capital, R capital, 2, C capital, R capital, 3, C capital, R capital, 4, C capital, R capital, 5, no, C capital, R capital, 6, no, C capital, R capital, 7, C capital, R capital, 8, no, C capital, R capital, 9 on. So I will write here 9 of offspring have tall stem and red flower. Okay? How many offspring have tall stem but white flower? So I will search about C capital and what are small. Yes, tall stem and red white flower. 1, 2, 3. 3 tall stem and white flower. 3. Okay. How many offspring have short stem and red flower? Short stem mean C small, red flower mean R capital. C small, R capital 1, C small, R capital 2, 3. Okay, so I will write 3. How many offspring have short stem, C small, and white flower, R small? Yes, only I have one only have short stem and white flower. Okay, so the ratio will be 9, 3, 3, 2, 1. 9 to 3 to 3, 2, 1. 3 dominant traits, 2, 1 recessive trait. Okay, as we said, I can put all we did together and see the second the second law, Mendel's second law, law of independent assortment of hereditary facts. Okay? When two pure different individuals, pairing two pairs or more of alternative or contrasting traits are crossed, the trait of each pair is inherited independently. Each trait inherited of the other and appears in the second generation at a ratio 3 dominant trait to 1 recessive trait. As we said, when two pure different individuals, as we said, two pure different individuals, tall stem with red flower, short stem with white flower, pure but different. The first generation will be 100% carry a dominant trait, okay, but hybrid. Each trait is inherited individually, separated, okay? After that, what about the second? The second generation or the second offspring carry the traits at ratio 3 dominant to 1 recessive. 3 dominant to 1 recessive. Okay? Mendel's second law. What is the difference between Mendel's second law and Mendel's first law? It's take care of two pairs or only one pair. If it's only one pair, it will be Mendel's first law. Two pairs of contrasting traits will be Mendel's second law. Okay? Thank you.